Hey everybody, happy Monday. Today we're going to look at bisectors in a triangle. You should have some pre-cut triangles in front of you. Some of them are acute, some are right, some are obtuse. Doesn't matter which one you grab, just make sure that they're nearby so you can grab them as we go along. Today what we are going to look at are the different ways that lines in a triangle will meet at a center. So the first one that we're going to do today, the first two that we're going to look at are called a circumcenter and an incenter. The points where various special lines of a triangle cross are called the points of concurrency. So let's write that in there. Points of concurrency is basically where they all agree. Okay. Again, we're looking at the circumcenter and the incenter. The circumcenter is what we're going to look at first. The circumcenter of a triangle is the point of concurrency of the perpendicular bisectors of a triangle. So grab one of those triangles that's in front of you. Again, doesn't matter which one. All right. What you're going to do is you're going to fold one vertex to another vertex. When you do that, the fold is going to create a segment that is going to perpendicularly bisect the side of the triangle. Okay, do that with all three sides. If you're looking at this diagram right here, if you were to fold vertex B to vertex A, you're going to have a line that's going to cut segment AB in half. Okay, you're going to create that midpoint, so X is actually the midpoint. You're going to do it again with A and C and vertex C and B. Play around with that a little bit. You may want to pause the video for that. Okay, I'm assuming you're back now. Once you do that, all those folds should meet at one point. They should agree at one point. In this case, it's going to, or in the case of the drawing, it's going to meet at point P. Depending on what kind of triangle you grabbed. If you grabbed an acute triangle, then the circumcenter is going to be in the middle somewhere, kind of like this picture right here. If you grabbed a right triangle, that point of concurrency is going to be on the midpoint of the hypotenuse. And if you grabbed an obtuse triangle, you're probably flipping out right now because none of those points meet, and that's because that point meets on the outside of an obtuse triangle. What is so special about this is that the circumcenter is equidistant to the vertices. Let's explore what I'm saying there. If I'm looking at the circumcenter of this triangle, which is point P, it has the same distance from point P to A as from point P to B and from point P to C. Okay, kind of cool. All right. The next point of concurrency that we're going to look at is called the incenter. And just like the vocab word alludes to, the incenter is always going to be inside, that center is always going to be inside the triangle. So grab some more triangles, and this time what you're going to fold, instead of vertex to vertex, you're going to actually take the vertex and fold it in half. And this is a little bit trickier, but try your best to fold it in half. What you're doing is you're creating an angle bisector. Up top, what we were doing with the circumcenter is we were creating perpendicular bisectors. Okay, so here we're creating an angle bisector with our folds. Take some time, go ahead and do that. Just remember that all the points of concurrency, doesn't matter what kind of triangle you've chosen, will be inside the triangle. So you're not going to have any special case like the right triangle or the obtuse triangle. They should all be inside the triangle. So pause it and have fun with that for a little bit. Okay, I'm assuming you're back with me. What you found out is that what is special about the incenter is that it is equidistant to the sides. So again, that angle bisector, that point of concurrency, if you draw a line perpendicular to the sides, okay, and if you had a compass, and we'll try to do this when I come back. If you had a compass and you put it on point P, you could draw a circle from that point P, and it would touch all the sides. Okay, again, it is equidistant, a perpendicular distance, equidistance to the sides. Okay. Let's kind of play around with it, see how we can use it with doing some little basic math here. Can we find the circumcenter from a graph? So let's go ahead and plot these points. Point P is at 0, 6. O is at the origin. S is at 4, 0. Okay, so let me draw my triangle in. Okay. All right, so again, remember with the circumcenter, you're folding, say, point P down to point O, and that's going to create a mid-segment of PO. Let me grab a different color and let's draw that line. That would put it at about right here. Okay, oops, let's try that again. Okay, all right, let's do one from O to S, halfway in between there. If I were to fold those, it would be along this vertical line right here at x equals 2, it looks like. Okay, where they meet, it's going to be right here at 2, 3. That's going to be our circumcenter. That is actually the midpoint of PO, the midpoint of OS, and the midpoint of the hypotenuse PS. Okay. All right, let's play around with a little more math. We've got triangle ABC over here. We've got some information over to the side, and we need to find the length of DA and the length of AB. Well, here's one thing that I know. I know that with a circumcenter that the distance from the circumcenter to the vertices is congruent. So I know that if DC is 2 units, then also BD is 2 units, and DA is 2 units. Okay, I also have to find the length of AB. Just add those two together, and that's going to give me 4 units. Okay, we need to find out why is triangle ADF congruent to triangle BDE. Okay, so here's ADF. Okay, and BDE. How do we know that those are congruent to each other? Well, I know that AD is congruent to DB because they are equidistant to the vertices. I also know that AF is congruent to BE because AC is congruent to BC and DF is a perpendicular bisector. All right, so in that case, angle BED, I'm running out of room here, guys, is congruent to angle AFD. Okay, they are right triangles. We can prove this by HL. Okay, so now we're going to switch gears from the circumcenter to the incenter. Okay, so remember with the incenter, we're dealing with angle bisectors. Okay, and that incenter is equidistant to the sides. Okay, So VY should be 3, and VS should also be 3. Okay, so there's your answer for the first one. How many units is VS? It's 3 units. Okay, and the next part, we are going to find the measure of VZX. So VZX is what we're looking for right over here. Okay, so what is given is that this information right here tells us that we are dealing with an isosceles triangle. Okay, so if we are dealing with an isosceles triangle, we know the base angles are congruent. So if this is 20 degrees right here, this is an angle bisector. I know this is 20 degrees. Since this is an isosceles triangle, angle VZX is going to also be 20 degrees. Okay, so very quickly, explain why XSV is congruent to triangle ZTV. We know that SV is congruent to TV, okay, because they are equidistant. I know that angle VSX is congruent to angle VTZ because they are right angles. Okay, we know that angle VXS is congruent to angle VZT because the isosceles triangle. And we're dealing with this angle bisector. So angle XSV, and I should have said triangle XSV is congruent to triangle ZTV by angle, side. Okay, this was my first little foray into videoing a lesson, so when I come back on Tuesday, we'll take care of any questions or issues that we had, but I think you'll have a decent time with the prep work. When you're looking at the first two, you're talking about angle bisectors. When you're looking at 3 and 4, you're talking about perpendicular bisectors, and you're going from there. Again, I think you'll do okay. Feel free to send me a message and I will try to answer. Thank you.